Hello, everyone. This is homework 5. My apologies for taking so long to get it out to you. The week got away from me. Let's go ahead and get started. So, for question number 1, use a cofunction to write the expression equal to cosine of pi over 10. So, the concept here that you want to understand is a cofunction. And basically, when we're dealing with trigonometry, tri means 3, gon means side, metry means to study of. So we're studying right triangles. So when we're talking about the cofunction, what we know is that the sine of this angle, let's say, is going to be the cosine of this angle, and vice versa. So we know that in radians, we know that pi over 10 plus whatever goes here is going to equal pi over 2, which is 90 degrees. The two angles of the triangle equal 90 degrees, which is pi over 2. So this angle plus this angle equals pi over 2. So if we change this to over 10, then we get pi over 10 plus whatever is here is equal to 5 pi over 10. Well, hopefully, obviously, what goes in here is 4 pi over 10, which simplifies to 2 pi over 5. So if one angle is pi over 10, then the other angle is 2 pi over 5. So that means that the cosine of pi over 10 is equal to the sine of 2 pi over 5. Okay, I feel like I went through that kind of quickly. Let me know if you have questions about it. But understanding what you're looking at is important. Let's go. Find the reference angle for negative 3 pi over 5. So if you'll end up drawing this a whole lot if we do this class right. If we draw a unit circle here, we need to figure out what 3 pi over 5 is. Well, negative 3 pi over 5 is equal to negative 6 pi over 10. And the reason why I did that is to show that this is greater than pi over 2, or negative pi over 2. Or in other words, negative 3 pi over 5 is going to be like over here somewhere. Okay, so the reference angle is going to be, how far is it from the angle to the nearest horizontal axis? So if this is negative 3 pi over 5, what they're asking is how far is it from here to here, which negative 3 pi over 5 plus what is equal to negative 5 pi over 5, which is negative pi, which is that. This is pi. Pi going positively. Pi going positively. Negatively, it is negative pi. Same thing. And we understand that the reference angle is 2 pi over 5. Whoa, sorry about that. All right, as always, if you have any questions, ask it. I'm trying not to go through this too quickly. I don't know. Maybe it's just I'm excited about it. All right, let's keep going. Here it is. So find the reference angle for negative 468 degrees. So the reference angle is between 0. The reference angle is between 0 and 90 degrees. Not equal to 0. That's not a reference. 0 to 90 degrees. Actually, I don't think it equals 90 either, now that I mention it. 0 theta 90 degrees. Okay, so in other words, for this, what we're going to do is we're going to add 360 to this however many times to get a number between those. So I do negative 468. I would advise a calculator plus 360. That's equal to negative 108. That ain't it. Add 3 more 60. Whoops. No. Negative 108 plus 360. And I get 252 degrees. So if I look at 252 degrees, that is about, believe it or not, 252 is right around here. is right around here somewhere if we're using this circle. 252 degrees is here. So the question is, how far is it from 180 to 252? Because that's what we're looking at. So minus 180, and I end up with 72 degrees. All right. Idea reference angles are between 0 and 90 degrees. Okay. And on a circle, a reference angle is going to be how far is it from wherever the angle is located to the nearest horizontal axis. So in quadrant 1, it'll be here. Quadrant 2, it'll be here. Quadrant 3, it'll be here. And quadrant 4, it'll be here. So there's a little formula. Well, let me just show you the formula. In quadrant 1, the reference angle is going to be theta. In quadrant 2, the angle is going to be 180 minus theta. In quadrant 3 is going to be theta minus 180. In quadrant 4 is going to be 360 minus theta. Theta being the angle measure. So that's really helpful. That'll help you. Let us continue. Determine which quadrant the terminal angle of theta lies. Let's do this. This will help us. Cosine, so our quadrants are 1, 2, 3, and 4. Okay. If cosine of theta is less than 0, and cosine is our x value, that means that we are over here on the left side in the negative part for our x values. And sine theta is less than 0, that means we're beneath the x-axis. So that puts us over here. That is quadrant 4. Okay. For B, so for B, I'm sorry, it's quadrant 3. I can't add. It's quadrant 3. All right. So for part B, cosine is less than 0. So we're in either 2 or 3. And tangent theta is greater than 0. So we know that tangent is equal to sine of theta over cosine of theta. All right, which is y over x. All right, tangent theta is positive here and here. When x is either both x and y are positive, or x and y are negative. Okay, so if tangent theta is 0, is greater than 0, and cosine is less than 0, then we're over here, and that's quadrant 3 again. Okay, again, ask questions about this. This is kind of the important part. Everything else that we do is built off of what we have going on here. Let's go. All right, so let -5, -3 be a point on the terminal side of theta. Easiest way to do these. Boom, so -5, -3, boom. We'll say -5, -3. Drawing a picture on these is going to be the big deal. Boom, boom. Make a triangle of it. This is trigonometry. So about all these beeps of my phone. So in other words, this is -3. This is -5. All right. The first step is for us to do this. We need to find the hypotenuse. The hypotenuse is always going to be positive. So we have -5 squared plus -3 squared is equal to h squared. It's 25 plus 9 is equal to h squared. So it means that 34 is equal to h squared. So root 34 is equal to h. Okay, always the first step. So let's go. Cosine of theta. Theta is going to be this angle here. So cosine of theta is going to equal, yeah, I'm going to run out of space, but cosine of theta is equal to adjacent over hypotenuse, which is -5 over root 34, which we can't leave like that. So this becomes negative 5 root 34 over 34. All right, remember that the hypotenuse is always positive. Okay. They ask for the cosecant of theta. We'll find the sine and then flip it. Because, yeah, we'll just find the sine and then flip it. Or we're using the triangle, so it'll be easy. So cosecant of theta is equal to, if sine is opposite over hypotenuse, then cosecant is going to be hypotenuse over opposite, which is root 34 over negative 3, which is the same thing as negative root 34 over 3. Easy. And tangent of theta is equal to opposite over adjacent, which is 3 over 5. Remember that the hypotenuse is always positive. Remember that tangent in the third quadrant is always positive. Okay, so that wasn't bad. Question number 6. Let theta be an angle in the quadrant 3 such that sine of theta is equal to negative 4 over 5. So quadrant 3, which means it's down here, and sine of theta is equal to negative 4 over 5. Negative 4 over 5. That's always theta. Okay, so the first thing we have to find out is whatever this x is. So x squared plus negative 4 squared is equal to 5 squared, because hypotenuse is positive. X squared plus 16 is equal to 25. Subtract 16. X squared is equal to 9. So x is equal to 3, but we're in the third quadrant, so it's negative 3. Both are good answers. So now we solve. Secant of theta, cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent, which is 5 over negative 3, or 5 over negative 3. Hold on, let me just write it. Secant theta is equal to 5 over negative 3. Can't have a negative in the denominator, so we just say negative 5 over 3. It's the same thing. All right. And cotangent of theta, tangent is opposite over adjacent. So cotangent is adjacent over opposite, which is 3 over 4. Or negative 3 over negative 4, which is 3 over 4. All right. Question number 7. So a lot of the same thing we're saying. Let theta be an angle in quadrant 2 such that secant of theta is equal to 9 over 4. That means that cosine of theta is equal to negative 4 over 9. So we have a triangle in quadrant 2. Does not need to be drawn to scale. Negative 4 over 9. Negative 4, 9. And this is going to be y over here because we have to solve for it. So negative 4 squared plus y squared is equal to 9 squared. Or 16 plus y squared is equal to 81. Subtract 16 from both sides, and I get y squared is equal to 65. 7, yeah. So that means that y is equal to square root of 65. So now we go and find our sine, cosine, and tangents. All right, so the cotangent of theta is equal to Tangent is, this is theta. Tangent is equal to opposite over adjacent. So cotangent is equal to adjacent over opposite. So I end up with negative 4 over root 65. Can't have a radical in the denominator, so this becomes negative 4 root 65 over 65. Whoops, not 6. All right, and sine of theta is equal to opposite over adjacent, which is root 65 over 9. A lot of these problems are the same, and that is good for us because we want to ensure that we want to ensure that we know how to do all of this. So let us continue. Number 8. Let theta be an angle such that sine of theta is equal to negative 4 over 5. So our sine being negative means it's in either 3 or 4. And tangent is less than 0. That means that it's on this side. We always have to give you an indication of enough information to figure out which side it's on. So that's theta. So sine of theta is negative 4 over 5. We have to find x. So x squared plus negative 4 squared is equal to 5 squared. X squared plus 16 is equal to 25. That means that x squared is equal to 9. That means that x is equal to 3. And because we're on the positive side of the y-axis, namely over here, then we know that x is positive. So x is 3. Then we solve. So cotangent of theta if tangent of theta is opposite over adjacent, then cotangent is adjacent over opposite, which is 3 over negative 4, which is negative 3 over 4. All right, and the secant of theta, if cosine of theta is adjacent over hypotenuse, then secant is hypotenuse over adjacent, which is 5 over 3. Let's do more. Find the terminal point on the unit circle determined by 5 pi over 4 radians. Use exact values, not decimal approximations. So if you sketch your unit circle, you need to indicate where 5 pi over 4 is. Well, 5 is greater than 4. So we know that this is pi over 4. This is 2 pi over 4. This is 3 pi over 4. This is 4 pi over 4, because 4 pi over 4 is pi. So 5 pi over 4 will be down here. If we look on our unit circle, our point here is negative root 2 over 2, negative root 2 over 2. You learned that unit circle is important. Find the exact value of cosine of 3 pi over 4. So looking at our circle over here, 1 pi over 4, 2 pi over 4, 3 pi over 4 right here. And they want to know the cosine of that, which is the x value. Well, x is negative there. Okay. Breezing right along. Suppose theta, I'm going to stay up here so I can use some of this space. Suppose theta is an angle in standard position whose terminal side intersects the unit circle at negative 5 over 13, 12 over 13. So x is negative on this side, y is positive. So we'll say it is roughly like right there. So this is negative 5 over 13, comma, 12 over 13. Okay. That means that cosine of whatever this angle is here, I should have drawn this a little bigger. That means that the cosine of this angle is negative 5 over 13, and sine is 12 over 13. And if you know anything about Pythagorean triples, that holds. All right, so they want to know what is the cosecant of theta. That is, if I take the sine of theta and flip it, sine is 12 over 13, so cosecant is 13 over 12. Cosine of theta is negative 5 over 13. And tangent of theta, all right, well, tangent of theta is opposite of adjacent, which is 12 over negative 5, which is negative 12 over 5. Okay, note the point always can create a triangle. In your coordinates of your points are your cosine and sine values. You can easily find your tangent from there. 12. Unit circle, kind of the unit circle. The cotangent of 4 pi over 3. Let's draw it. Let's sketch it. I like to sketch it every time just to be sure, because I like to know where we're talking about. So 4 pi over 3, 4 is greater than 3. Okay, so this is 1 pi over 3 right there. 2 pi over 3 is up there. 3 pi over 3 right here. 4 pi over 3 is right here. Okay. So tangent of this point, well, the point here is negative 1/2 negative root 3 over 2. Okay, so the tangent of 4 pi over 3, I'm showing you how to do this so you can use it later, is equal to y over x, which is negative root 3 over 2 over negative 1/2. Some people may be intimidated by fractions. Don't be, because it's the same thing over and over. All right, so the 2's here, both of these 2's are in the denominator. They cancel, and you're just left with the top over the bottom, which is negative root 3 over negative 1, which is just root 3. That's a tangent. Okay, so the cotangent is, well, we'll say root 3 over 1, because the cotangent then is going to be 4 pi over 3. It's going to equal to 1 over root 3. But you can't have a square root in the denominator. All right, so you flip it. And you end up with root 3 over 3. Did you? Yes. Yes. Sorry, I was going through the tangent things in my head, because it's root 3 over 3, 1, root 3. So it makes sense that for cotangent it'd be flipped. So there we go. So the secant of 4 pi over 3, I take my cosine value, which is here, cosine value, and I flip it. And I end up with negative 2. Knowing the unit circle, knowing your unit circle and those trig values are going to be super duper important. Find the exact values below, and then if applicable, click on undefined. Well, you know the likelihood of us giving you something undefined is going to be really low. So first, the sine of 675, we need to know the reference angle for that. So we subtract 360. So 675 minus 360 is 315. Well, we know where that is. If you have your, I'll go up here. If you have your triangle, whoops, 360, 315 is like right there. Okay, but let's be thorough. So 315 and 360 minus 315 minus answer is 45 degrees. So our reference angle is 45 degrees, but we're down here. That means that the sine is negative root 2 over 2. Okay, knowing where you're located helps. Secant of negative 7 power 6. So we're rotating in a negative. I'll change to red. We're rotating this way now. So this is negative rotation. All right, so 7 power 6 is 1 pi. 7 is greater than 6. So in other words, this is located right there. Okay, and when I do that is, if it's less than 6 power 6 is pi, which is right here. It's halfway around the circle. So if it's greater than 6, then it's going to be past this. If it's less than 6, then it's going to be on this side of the halfway. So this is where we're located. And we want to know the secant of that. Well, we know that the cosine of that is, cosine of this point right here is negative square root of 3 over 2. Right? Okay, so that means that the cosine is that means the secant is negative 2 over root 3, which we can't have. Multiply both sides, both top and bottom, by root 3, and I end up with negative 2 root 3 over 3. And there's the secant of that. All right, let's continue. If theta is 4 pi over 3, you notice that looks terrible. Try to do a little better. That looks more like an egg than a circle, but whatever. All right, 4 pi over 3. 4 is 1 greater than 3. So we are over here. We're right here. And this point is negative 1/2 negative root 3 over 2. So 2 cosine of theta. Cosine is negative 1/2. So 2 times that is negative 1. Cosine squared of theta. That's the cosine of theta squared. Cosine squared of theta is the same thing as cosine of theta squared. That'll help you in the future. All right, so in other words, it's 1/2 negative 1/2 squared. Negative 1/2 times, whoops. I feel like I'm rushing. Negative 1 over 2 times negative 1 over 2. This is equal to positive 1 over positive 4. Well, all right, so cosine of theta over 2. So in other words, we're doing the cosine of 1/2 times 4 pi over 3. Because dividing by 2 is the same as multiplying by 1/2. So this becomes, I can do 4 pi over 6, or I can reduce it. Well, I'll just do it like that. I'll be thorough. Cosine of 4 pi over 6, which reduces to cosine of 2 pi over 3, which is on the circle. 4 pi over 3 right here. 2 pi over 3 is right here. And the cosine of those two things are the same. Boom. All right. Last problem for this section. Suppose x, 3 over 5 is a point in quadrant 2 line on the unit circle. So as is common, we're drawing our unit circle again. Quadrant 2 is over here. And this x, 3 over 5. X, 3 over 5. Find what x is. Okay, so as is always, we draw a triangle here. Okay, we know that this is the sine of theta. So in other words, this is 3. This is 5. Now we just have to find that. If you're familiar with Pythagorean triples, you already know what this is. We've also done this in a couple of problems, but let's be thorough. This x right there. So we know that x squared plus 3 squared is equal to 5 squared. X squared plus 9 is equal to 25. Minus 9. X squared is equal to 16. So that means that x is equal to 4. but we're in the quadrant 2, so x is -4. So in other words, our x here, which is our cosine of this angle, is -4/5. And there we go.